Hello everyone, welcome back to my YouTube channel. In this week's video, I'm going to explain to you how you should answer quiz 2 questions. Altogether, we have 5 different questions and let's start with the first one. Question number 1. Mr. Mike does 30 kJ of work on 2 kg of water by stirring it using a paddle wheel. While stirring, 20,920 joule of heat is released from the water through its container to the surface and surrounding by thermal conduction and radiation. Determine the change in internal energy of the system. Alright, so if you look closely to the question, it states here that 30 kJ of work is being done on 2 kg of water. Therefore, we can consider that the water is equivalent to the system, right? Then the work is being done by the system because 30 kJ of work on 2 kg of water. Work is being done on the system. So work should be positive, right? And then we can see here that 20,920 joule of heat is released from the water. So, since the heat is being evolved by the system because it's being released by the water, therefore your Q should be negative. In the question, you were asked to calculate the change in internal energy. So, the change in internal energy, which is delta U, is equivalent to Q plus W, right? From the question, you were given the values. So Q is the heat. So your Q is 20,920 joule. But Q is negative, so you need to put negative there. Plus your W, which is the work, is 30 kilojoule. Right. So you need to understand here, this one is in joule and this one is in kilojoule. Therefore, you need to convert this one into joule. So negative 20,920 joule plus 3.0 times 10 to the power of 4 joule is equivalent to 9.0800 times 10 to the power of 3 joule. So this is the final answer for the first question. Moving on to question number 2. 1 mole of gas at 47 degrees Celsius expand adiabatically until its volume in liter is quadrupled. Determine the work done given that the gamma is equivalent to 1.5. Okay, for this question, you have to do 2 different steps in order for you to get the work. So the first formula that you need to use is T2 divided by T1 is equivalent to the volume, initial volume, divided by the final volume to the power of gamma minus 1. Alright, so you don't know what is T2, but you do know what is T1, which is 47 degrees Celsius. So you need to convert this into Kelvin. Is equivalent to the volume. So initially we can consider that the volume is 1 liter and then is quadruple. So it means that 4. And then the gamma is 1.5 given in the question minus 1. Therefore, you will get your T2 is equivalent to T2 divided by 320 equivalent to 1 over 4 to the power of 0.5. Hence, you will get your T2 is equivalent to 0.5 times 320, which is equivalent to 1.600 times 10 to the power of 2 Kelvin. Right. So from here, then only you can calculate your W, which is work, equivalent to R, which is the gas constant, gamma minus 1, times T1 minus T2. Okay, so the gas constant that you're going to use is 8.31 joule per mole per Kelvin divided by gamma minus 1. So we already calculated this. It should be 0.5. Hence, you need to do T1 minus T2. So T1 just now is 320 minus 160. These are in Kelvin. So you will get 1.3296 times 10 to the power of 3 divided by 0.5. So your final answer should be 2.6592 times 10 to the power of 3 joule per mole. So this is the final answer for the second question. Question number 3. A combustion reaction in a piston decreases the internal energy of the reactant by 750 joule and increases the volume in the piston from 0.2 liter to 0.6 liter against a constant external pressure of 8.0 atm. Predict the heat for the combustion reaction. Alright, so from this question, it states here that the combustion reaction in a piston decreases the internal energy of the reactant by 750 joule. Therefore, we can know that your delta U is actually equivalent to 750 joule. Okay, so since we have this data, so you can use delta U is equivalent to Q plus W. But in the question, predict the heat of the combustion reaction. So you want to calculate Q. So you need to rearrange this equation. Q is equivalent to delta U minus W. Alright, so what about W? In this question, you were not given the value of W as is. So you need to convert this W into other formula as well. So from the notes, we know that W is equivalent to negative P delta V. So you were given the change of the volume and the pressure as well. So basically you can calculate the value of W, which is negative P, which is the pressure, 8.0 atm, and then delta V. So delta V must be the V2 minus V1. So your V2 is 0.6 minus V1 0.2. Here you will get negative 8 times 0.4. So you will get your W is equivalent to negative 3.2 liter ATM. Okay. Alright, so now we have to check again. For your delta U is in joule, but here your W is in liter ATM. So what we have to do now is we need to convert this into joule. So you need to remember that 1 liter ATM, the conversion is into 101.3 joule. So in other words, you need to times this with 101.3. Therefore, you will get your W is equivalent to negative 3.2416 times 10 to the power of 2 joule. Okay, now only both of the units are the same. Therefore, you can calculate your value of Q. Alright, so I'm just going to write again. Just now we know that your delta U is equivalent to 750 joule. And we have calculated just now your W is equivalent to negative 3.2416 times 10 to the power of 2 joule. Therefore, you can calculate the value of Q is equivalent to delta U minus W. So your delta U is 750 joule minus negative 3.2416 times 10 to the power of 2 joule. Therefore, you will get your Q is equivalent to negative 4.2584 times 10 to the power of 2 joule. So this is the final answer for the third question. Let's move on to question number 4. The reaction between zinc oxide and carbon was conducted at 25 degrees Celsius. The enthalpy and the Gibbs free energy for the reaction was found to be negative 957.8 kilojoule and negative 935.3 kilojoule respectively. Calculate the entropy for the reaction. Okay, this is a rather straightforward question. So you were asked to calculate the entropy, which is delta S. So how you're going to get delta S is by using the formula delta G system is equivalent to delta H system minus T delta S. Alright. So the rest of the thing is given to you in the question. Like for example, the temperature is 25 degrees Celsius, and then the enthalpy and the Gibbs free energy, which is the delta H and delta G, is given to you as well. So now what we are going to do is just plug in this value. For instance, the delta G is negative 935.3 kilojoule. Is equivalent to your enthalpy, which is negative 957.8 kilojoule minus the temperature is equivalent to 25 degrees Celsius, but you need to convert this into Kelvin, 273, and then you will have your delta S. Okay, so from here, what you need to do is we just have to make this bracket over here, so you can calculate your delta S. So you will get negative 298 delta S is equivalent to negative 935.3 kilojoule plus 957.8 kilojoule, which is your enthalpy. Alright, so here you will get your delta S is equivalent to negative 22.5 kilojoule divided by 298 Kelvin. So you will have your delta S is equivalent to negative 0.0755 kilojoule per Kelvin. So this is the final answer for the fourth question. Alright, so we are now at the final question for this week video. Consider the following enthalpy and entropy data for water in both liquid and gaseous state. Determine the change of Gibbs free energy for the vaporization of water at the temperature of 25 degrees Celsius. Right, to answer this question, the first thing that you need to look at is this vaporization of water, because if you get it wrongly, so the product and the reactant will be different. So in a way, we will say that it's water, H2O, from liquid to be vaporized into water in the gas form. So the first thing that you need to do is you need to calculate your delta H. So we are going to look at the value for delta H. So delta H is the summation of delta H formation of product minus the summation of delta H formation of reactant. Okay, so your product is in gaseous form, which is this one, so negative 241.82 kilojoule per mole minus the reactant negative 286.83 kilojoule per mole. So from here you will get your answer will be 4.5010 times 10 to the power of 1 kilojoule per mole. Right. So this is the first step. So now we are going to calculate what is your delta S. So up next we are going to calculate your delta S. So it's going to use the same formula, the reaction. So we will have your delta S is equivalent to the summation of S, formation of product, minus the summation of S, reactant. So your product should be in gaseous form because it's vaporizing. So in gaseous form, 188.80. This is in joule, but you need to make sure that you need to convert it later on. So I'm just going to do 188.8 minus 70. Bear in mind this is in joule mole per Kelvin. So your final answer will be 1.1880 times 10 to the power of 2, but this one is in joule per mole per Kelvin, right? So you want to make this joule into kilojoule, so you need to divide with 1000. Therefore, you will get 1.1880 times 10 to the power of negative 1. Now you will get kilojoule per mole per Kelvin. Alright, so we have calculated the value of delta H and also delta S. Therefore, we can calculate your delta G, which is equivalent to delta H minus the delta S. Alright, so your delta H is equivalent to 4.5010 times 10 to the power of 1 kilojoule per mole. So you want to minus your T, 25 degrees Celsius, so 25 plus 273, because you want to convert it into Kelvin, because here you have Kelvin, times your S, which is 1.1880 times 10 to the power of negative 1 kilojoule per mole per Kelvin, right? So from there, you will get, you just have to press your calculator at the end, you will get 9.6076 kilojoule per mole, right? So this is the final answer for the last question for this quiz. Alright everyone, so this is the end of this week's video. I hope that this video will help you to understand more how you should answer all the questions for Chapter 2 quiz. So I'll see you again next week. Thank you very much. Take care and be good. Goodbye.